section 2.5, and it's the first video in this section. Today we're going to be covering the zeros of polynomial functions. Now, the goal of this video is to solve polynomial functions when we're not given any zeros and the polynomial doesn't factor. We're going to have a three-step process to do this. The first step in this process is going to be called the rational zero theorem. Now, the rational zero theorem says that the possible zeros of a polynomial are p divided by q, where p is the factors of the constant, now the constant would be the number without the number without an x, and q is the factors of the leading coefficient. So let's just go ahead and look at an example. We want to find the possible rational zeros of this given polynomial f of x. We're going to continue to work with this polynomial throughout the first few examples of the video. Now, the first thing to decide is what are our p's. The constant is -6, so we need to list out all the factors of -6. That will be plus or minus 1, 2, 3, and 6. Now in this case, our q is just the 1, because the 1 is the number in front of the highest exponent. So the only factors of 1 are plus and minus 1. Now, I would have to decide and list out all the p divided by q's. In this case, since our q's are plus or minus 1, our answer here, our possible rational zeros, are just the p's. Now remember, these are the rational zeros. There could still be irrational zeros, but we can't find those using this theorem. The second step in this process is going to be to use Descartes' rule of signs to determine how many of those zeros are positive and how many of the zeros are negative. So, we'll work through the steps with an example. Here's the same function we had in the previous example, and we want to find the possible number of positive zeros and the possible number of negative zeros. The first thing we need is f of x, and then we'll also need f of negative x. We found f of negative x when we did even, odd, and neither functions. It's the same process. So let's find f of negative x right now. I'm going to plug a negative x in place of all my x's. And then we'll go ahead and simplify. When I do that, we get negative x cubed plus 2x squared plus 5x minus 6. Now that I have f of x and f of negative x, I need to look at the number of sign changes. So as I go throughout each of those individually, we want to see where do the signs change from positive to negative. Now this is different than even, odd, and neither. We're not going to compare f of x to f of negative x. We're going to look at them as two separate ones. The answers for f of x are going to be our positive zeros. The sign changes for f of negative x are going to be our negative zeros and how many we have. So let's go ahead and look at f of x, and we'll find the number of positive zeros first. If I look at f of x, we go from a positive to a positive, and then a positive to a negative. That would count as one sign change. Now we go from negative to negative, so the total here is one sign change. Now for the negatives. When I look at f of negative x, it looks like I go from a negative to a positive. That makes 1. We stay positive, and it looks like we have another sign change right there. We go from positive to negative. Now, in this case, that means there's two negative zeros. If we go back for a minute to step 2, it says the number of zeros is the number of sign changes, or less that by a positive even integer. Basically what that means is keep subtracting 2 until you get to 1 or 0. So basically, in this case, we said there's 2 negative zeros. We can subtract 2 from that, and we get 0. This means there's 2 negative zeros, or there's no negative zeros. There's a possibility of either of those. In terms of the positive zeros, if I subtracted 2 from that, I get less than 0, so we'll leave it at 1. Now, if we think about what this means, let's go back for a minute to this list that we came up with in the previous example. In the previous example, we listed 8 possible rational zeros right here. What we just figured out is that our actual zeros, there's either one positive, well there is one positive, and then there's either 2 or no negative zeros. That's what that means. That's what we just figured out. So one of those positive numbers is going to work in either 2 or none of the negative ones. So what we're going to do now is we're going to take that information we just figured out and we're going to use it to actually help us find the zeros of our given polynomial. Now, in order to do this, we're going to use our synthetic division process that we've learned in previous sections. Remember, if a number is a 0, then when I use synthetic division, I should get a remainder of 0. So if a number is a solution, it should give us a remainder of 0 in synthetic division. It should go evenly into this polynomial. So we need to decide where should we start. And this is just now a guessing game. We're just going to pick a number and give it a try. Now, looking at what we decided with Descartes' rule of signs, I know for sure one of these positives is going to work. We're going to start with the positives, and let's just try them. And we can pick any positive we want. I'm going to start with positive 1. And I want to see if positive 1 is a 0. So I'm going to go through my synthetic division process with positive 1. Drop down to 1. We get 1, 3, multiply, add, multiply, add. I did not get a remainder of 0 here. I got a remainder of negative 8. That means that positive 1 is not a 0. So now we just try again. Let's try with positive 2 this time. Multiply, add, multiply, add, multiply, add. We got a remainder of 0. That's fantastic because that means that x equals 2 is one of our solutions right now. We need to come up with the rest of the solutions. Now, there could be 2 or negative zeros out of my list. There could also be zeros that are not rational. Now, if they're not rational, they're not going to show up in this list that we came up with for our P over Qs. So what we can do now, we could continue to test the rest of these negatives, all the negatives, using our synthetic division, or we can look at what's left. And if I look at what's left here, we've got an x squared, 4 x's, and 3. And we can go ahead and just solve that equation. And the nice thing there is that one is a basic x squared. We can factor this. There's a coefficient of 1, so I'm really just looking for 2 things to multiply to 3 and add to 4. And that's x plus 3 and x plus 1. So our 2 negative zeros are negative 3 and negative 1. And we now have our 3 solutions to this polynomial. So we were able to solve this polynomial without having to factor. We used, well, factor from the beginning. We used synthetic division to find 1 0, and then we factored what was left. We're going to try more of these tomorrow in our video. Right now, I just want you to go ahead and answer this question. Number 1, you're going to list all the possible zeros of this function. So just the possible, the p over q's. Right in this one, you're finding the p over q's. Question 2, I actually want you to go through and try to find the zeros of this one. So go through that 3-step process that we went through in our example. Be prepared to share your answers tomorrow in class.